Hi everyone and welcome to this DSA Mastery course, and in this video that I promised that from this video I'll be talking about a stack using linked list. This will be the only one lecture, I think so, but I don't know. So the stack using linked list. Okay, so in the couple of previous videos we had talked about stack using arrays, and we have also taught in second video we have talked about kind of taking out a time complexity as well as the modification in our stack with arrays. Okay, so we had done with arrays, and now it's time for a linked list. But before going into that, let's recap what a stack is, so that if you're a beginner you can be also on the same pace. But I highly recommend to go on a previous video. It is just for 10 minutes, so you can go on the first video of this stack and try to understand that, and then come back after watching arrays also video. Okay, so in general stacks are the dynamic data structure, and the notes is in description box below. It is one-pager note, so you can take a look at that if you want to go any examination or interview, or you want to just recap your kind of stacks. Or I've not written the code because I don't want to write the code under the paper. You can simply watch this video, take a print of whatever the right of the code, whatever the code you have written, and then you can use it as a reference purpose. But I do highly recommend to make a note of how do you approach the problem, because everyone has a different mind of thinking. I'm just trying to make it as cool as possible as my mind is. Okay, so let's not focus on neuroscience, let's focus on stack using linked list. Okay, so let's a little bit recap actually what a stack is, so that we can on the same page. So a stack is just like a dynamic data structure. It follows a rule or a principle of LIFO, last in first out. Means the first one to be inserted, the last one to, means if you insert you can only insert the element at the top, or you can remove the element from the top only. Let's say you have a dining table. Everyone has, and on that dining table you have trays, a bunch of trays kept on together. So let's say you have a tray. This is your tray 1, this is your tray 2, this is your tray 3, and this is your tray 4. Okay, so you can only remove the tray from the top. You can add so you can remove the tray only from the top. You can't remove from this, and you can only add the tray on the top only. Okay, so that is the simple idea behind that stack. Stacks are just like you can only insert element at the top, you can only remove element at the top, and it's dynamic data structure. We'll see a real world like the applications of a stack also. Okay, so let's start talking about a stack using linked list. So actually let's a little bit talk about what happens in linked list. So in linked list we have a node, we have a nodes in which this is the data, and this is the kind of the pointer which points to the next array. So let's say I have this 10, it points to 20, it points to 30, it points to 30, and the next of this will be null. So the next is pointing to this, the next is pointing to this. So this is called the head, and this is called the tail, and the identification of a tail is just like if the next or the pointer of the tail is null, because it doesn't have anyone to point. Okay, so the tail, and this is our head, or we can say the top. Okay, so head and top, and it's very simple. If you want to get into this element, so you can write head dot next, so it will give 20 because head dot next is pointing to this, so you can do that. Okay, so this is a simple idea behind also linked list. So now let's get back to our what's our a procedure for making operation. So first operation that we'll make is push. Okay, so first operation will make push. In arrays we have made push just like it is very simple, that we had just if the size of our array is full, we can double the capacity of our size of our array, and then we can then we can insert just like increasing the size and putting the element at the top. Okay, if you want to get more detail, please get back to this previous video or the previous video. Okay, so in linked list, what I'm thinking to do is I will go, let's say you have this node 1 is pointing to 2, 2 is pointing to 3, and let's say you want to insert, let's say you pushed 4. So you will go till last -1. So you will go till here. You will go till here, means to the last node. This is the tail. You will go to the tail, and in the next of this, you will insert 4, and the next of 4 will be start pointing to null. Okay, so on the next of this, you will insert this 4. Okay, so you will, and then you have inserted this. So it is fine that we are able to push that, but there is some kind of problem in the complexity or the time taken by this. So we are just dealing with the size over here. We are just looping. We are just looping over to n times. We are going to the last element or a tail. Means we are doing here. We are going here. We are going here. It's last end. So it is dealing with the size. So it's taking O of n times, order of n times. Okay, so it is taking order of n time, and this is not good, because in arrays it's just taking order of 1, but in some cases it's taking order of n. On an average this is order of 1, but in linked list it is taking order of n. So what we can do, and any kind of idea, we have already talked about in linked list that we are given this, we have take with this, and also we can take tail. So we can also take tail. Okay, so let's say you wanted to insert kind of a you will also take head as well as tail in this for making an order of 1. So you will take head as well as tail, and then you can simply make this as a the next of this to pointing to the new node, and then new node will start pointing to null. Okay, so it is good. Now it is order of 1, because we simply know the tail, and simply we can make the tail that next equals to the new node that is being present there, and okay, this is okay. Now we are done with push. Now we had got order of 1, and we are good to go. Okay, now let's talk about pop. What happens in case of pop? What actually happens in case of pop? So let's say you wanted to delete the element. So let's say you have 1 pointing to 2, 3, and you want to delete, and you call the pop. You call the pop, and pop will delete, because in stack you have only move or insert at the top. So you can remove. So you remove this. How to remove this? You go with the last element, so you go with the last tail, and you simply cut down that the previous, means you go till here, previous last -1, so last -1, which is the previous, and you cut down the next to be the pointing to null, and this is already gone. Okay, so you start pointing to null, so you're traversing it to previous -1, so it is taking order of n, order of n times. We are going to n times, n-1 times, so it is taking order of n times. So it is not also good. It is also not good, because in array it is this clear cut to cut that it is more efficient. It's order of 1. So how do we deal with that? For dealing with that is very simple. What we can do is it is not simple again. It's what we can do, not what we can do. We can think of doing. So what we can think of doing is, let's take in here we are taking head as well as tail. Let's take head as well as previous. So last -1 means previous. We can take this as previous. Okay, so we are here in previous. Okay, so you call the pop, and 2 is deleted. Sorry, 3 now 3 has deleted. Previous is start pointing to null. But what if you call pop once again? Now previous is to S2, so now what will happen? It will delete its own? No, it will not be. What will happen? You can't go back. You can't go back. So what you will do in this case? So it is not the kind of a. It is not kind of a. It will not work. Eventually, it will not work. As I'm telling you, it will not work. So what we can do here? What we can do, I have to make you familiar with another approach of dealing with the push and the pop. Okay, so let me, it is order of n. So how do we deal with this? So for dealing with this, very simple. Again, it's very simple that what we can do is, here we are pointing 1, 2, 2, 2 to 3. here, and what we can do, let's say you want to insert push, you call push 4. Okay, so what we can do, we can insert push, we can insert the kind of at the head, we can start pointing push to 4 here. Okay, we can make this as a head, so we can make this new node as a head, and head.next will start pointing to this. So we can update the head means push, and not on the right side, on the left side. And again, it's clear because in tag you can only insert the top and delete from the top. Okay, so you can do that, you can do in linked list. So what you can do, you can simply make it kind of at this side by pointing 4 to by making 4 as a head, and for the next pointing to the first that previously had. Okay, now it is good to go. So it is not taking anything, it is just kind of we are just inserting, we are just head equals to the new node, and new node dot next pointing to kind of a previous head. First of all, we have to do new dot next with pointing to head, and then we can simply update our head equals to new node. Okay, we can do that. So it is not a big deal. It is just taking order of one time and push. Okay, again, it's very simple, means the previous is also taking one order of one time, and this also taking one order of one time. Okay, so let's say you want to delete or pop. Let's say you call pop. Let's say you call pop, and what will happen, what we can do in this case, we can simply this is our head that we have inserted, this is our head, and we can simply make this head to the pointing to the head dot next. Head dot next, so head dot next is this, now head is here, now it is cut off. So it is not doing, it is just doing this one line of code, means simply not doing anything with sizes. Pop is also order of 1 now. So we have done all those things, we have got our good accuracy, sorry, no, I'm talking about ML, it is just, you're getting a good kind of a efficient algorithm or the implementation, a code. Okay, so I think you have enjoyed this kind of how to approach the problem in this, and again, the notes and description I'm below, and I'm not going to give you this source code, because given the source code is not kind of you try it out by yourself. If you can try it out just now, go there and write the code. But if not, don't worry, it's even I was not able to implement that. Okay, so let's start by coding it a little bit. Can be coding stack using list. I will be coding a little bit faster, and I'll return the function that we will implement. So here it is. Okay, so let me make one function, let me make one class which is stack using, I don't want to misspell, linked list. I think this big name is okay, and then we will click on finish. Okay, so first of all, what we will do, we'll make this stack a generic class, okay, so we can put integer, floating point number, double, etc. So we can make this integer, sorry, kind of generic. So all the things we will make generic over here. Okay, so first of all, we want actually the head, we want the head private, we want the head of our node. Okay, and we are just providing t over here because we have generics, and we are making private because I don't want anyone to update my head. Okay, and what I can else do, I can simply take the size, or I can say in the arrays we're taking the top, but size is what we have to do in push or pop. Okay, so we are just going to take the size of our the size will be in integer format. Okay, pretty much easy. Now let's make one constructor. Let's make one constructor public. Let's make one constructor public, and it's to stack using linked list. I think I can write LL, but no, it's stack using linked list. And then what I can do, I can make point head to null, because we have head which is null, and our size which is equals to just now, which is equals to 0. And if you do not do this, it will be the same because it has a primitive and the generics. Okay, but let's do it for formatting point of view. Okay, so now let's start making our function. So first function that we'll make is size. So let me copy this function that we are going to make. Okay, so let me it is more efficient if you write this out. Okay, so we'll make size is empty top push pop, and in a fast way. So size, how do you take out a size? We can just write a function which is it will return int, And I think are you all able to see over here? Okay, so size is very simple. So size, you call the size, and let me make it a little bit small because I think I have seen all the people doing it small. Okay, size, and it will return only the size, because size is 0, it will return 0. If we update, if we push the size, we will update the size by 1. If we insert some element, we update the size in. You will see just in a second what we are doing. Okay, so it will return simply the size. Is empty means the size is equal to 0. If it will be boolean, means is empty means true or false, so it will be just return the size is equals to 0, and it is good to go. Okay, so we have made the one empty is empty. Now what we can do, we can make one function which is called the top. Means it return the top. What is the element is the top? What is the node? Okay, so then the element at the top. Okay, so what I can make is I can it is the top is simply the kind of it will return the element at the top, so it will be t top, and we are good to go. And then what we can write, we can write like this. We can return the whoever with the head dot data, and it is good to go. Okay, but what if our linked list is empty? So we have to write the exception. If our size of our linked list is equals to 0, then we will throw an exception. So stack, and the previously I made that stack full exception, sorry, empty exception e equals to new. Let me copy this if I can, and this is good to go. And we can write throw e. Okay, so we are good to go, and it is good to. And one more thing, that we have to write the declaration, and it will return the data, means the data at the top. Okay, next function, push. Okay, so push will return nothing. Push will return eventually nothing. So the void, and we have push, and it will just take the element. So the element will be also generic because we don't know what an element is. So element, okay. And here one more thing, that in the arrays we are doubling the capacity, means we are, if our array is full, we are double, but in linked list we don't have that. We can insert as many as element we can, just writing the, just making, we don't have to care about the size of our linked list, because linked list does not have a finished size. Okay, so now if we want to push an element, first of all what we can do, we can make a new node. So let's make a new node and put that element into the new node. So okay, so new node equals to new node, and it will run generics, and it will convert that element into the node. Okay, so here will be the data, and the next will be the next just now. Okay, so what we can do, first of all, we will have to new node dot next. We'll start, because I've just shown you that here we can point here, this our head, and in the this our head. Now we can, what we can do, let's say we have made a new node, so this is our new node, so new node dot next, and we can update the head to this. Okay, because I've already talked about this in detail. I spent a lot of hours over there for making understand in my linked list tutorials. So new node dot next will contain the head that is already being there, and now we can update the head. But if we do it kind of firstly, so we will lose our we will lose our links. Okay, pretty much easy. Now we are done, and we can increase the size that our element is here. Just now we have a size 1. After this, after 1, then size 2, size 3, size 4, size 5, etc. Okay, now next will be the pop. I think so. It is a pop. Yeah, exactly. It is a pop. Means you want to delete the element or remove the element from the top. So how you can do that? For doing that, it is again the generic. We will print out the one we are deleting. Okay, so it will be generic. Okay, so it will be pop, and we are not going to, it's just a pop from the top, and So what will happen? So first of all, what we can do, we can take the temp data. So the temp, we can take the temp, which will be deleting. So it will be simply the head dot data, means we'll be only deleting the head and then making it point to this, means head dot next. Okay, so head dot data. Okay, so this is the one that, and we can update our head equals to head dot next. Okay, so if your head is this, you have call, if your head is this, you call pop, and head dot next is here, so head is now here. Okay, and now what you can do, you can simply kind of a size minus. Okay, and then return the one that you have deleted. Okay, and over. Pretty much okay, but one thing more I want to do. If our linked list is empty, what we can do? So we can just write the same thing that we have done in the previous. So if our size is equal to 0, then what we can do, we can write this again. This is the same exception over here. So we can write the same exception, and we can throw throe. Okay, but we have to do the declaration. So let me do the declaration, and you're good to go. Okay, pretty much easy. And now you are done with stack, implement a stack using linked list. And I hope that you got better familiar with all of this. And let's calculate a little bit faster here the time complexity. Again, the size is returning the size order of one times order of one time. Is empty, is just checking order of one. Top is just taking out the data order of one. Push, it is not doing anything, it is just making the head to the new node. Order of one. Pop, it is not doing with any of the size, because you can see we are not looping anything, so it is order of 1. We are not going n times, so it is also order of 1. So the whole code, means whole algorithm, means whole data structure we have written in order of 1, and it's more efficient, and it's efficient. Both arrays and linked lists, as per the problem statement, we will do that. Okay, so we have order of 1, all the function is good, all the things are good, and we are good to go. Now let's use this as we have done. And again, if we have made this new node over here, I have made already, that I've already talked about, a node over here that I made the constructor. If you can see that node over here that I already made. So if you can think that what I'm doing, it is just what I'm doing just now. The source code is not in the description. I don't want to put it in the description. Okay, because if I do, you'll just copy and paste. Okay, so let's stack using LL use case, and LL indicates that this is a linked list. Okay, finish it out, and let's try the same thing that we have done in a kind of a stack using arrays. Let me copy this if I can. Okay, but one thing we have to do, we have to make it integer. You have to make this integer. Okay, because it's generics. What I can do, I can make this again, and we are good to go. What is happened? So I have to write a stack using linked list over here. This is the one that I have to change it. Okay, pretty much easy. And is empty the same, means let me see if is empty. Okay, I is small, and that's the same thing. We are inserting, first of all pushing the 5 element, and we are removing the 5 element, and if we're removing, the all will be printed out. Okay, so let me run this out. Let me save this if I can. And what is the next step? So let me, I think this is the next step. Again, what is happening? I think some error over here. Oh, so I have to add the declaration that it will throw an error. Okay, save it, and now it will run fine. Okay, now you can see 5 4 3. First of all, 0 1 2 3 4 5 is inserted, and then 5 4 3 2 1 means from the top it has been deducted or removed. And I hope that you got better and better intuition about linked list. And now we are good to go. We are done with the stack using arrays and linked lists. In the next video, guaranteed some more a real world problem on stacks will be coming up, and then it'll go with queues, and then trees, doing a lot of problems on trees, and then we are close to our ending pad, but there's a lot, dynamic programming, binary search trees, etc. I think so. Okay, so this will be around 50 to 60, not 50 to 60, it will be 100 to 200 video, because I'll be putting a lot of problem statement over here. So I think that you got better familiar with this. I'll be catching up in the next video. Till then, do support me by simply subscribing to this YouTube channel. I didn't ask for anything. I just want to ask for subscribing and watching the tutorial at the end. Okay, so this is not my kind of a good benefit, and I just was kind of it motivates if you subscribe this YouTube, and then like that. What I can say. Okay, so that's it for this video. I'll be catching up in the next video. If you have someone who can support me, simply consider subscribing to this YouTube channel. Thank you for seeing this video. I'll be catching up in the next video. Till then, bye bye.